Hey, and welcome back. Today I want to look at these two things, which are brushless fans. They are kind of like the turbo style fan, where how this works, if you don't know, is this is like a toothed, we call this a squirrel cage. And basically the point of this is there's a motor on the inside here that spins this in this direction, the arrow here. I don't know if you can see that guy there. And what it does is the blades kind of swirl the air around. The centripetal or centrifugal or whatever the force is pushes the air to the outside of this housing, and the swirl effect plus the fact that it wants to be on the most outside as possible forces it around this bend here and accelerates it and then out this hole. These things were in a scrap heap, so it's possible they don't work anymore, but they look like two different brands of pretty much the exact same fan. They are 12 volts, 1.35 amps a pop, and we're going to give them a shot. So I'll bring in my power supply here. I'm going to set it to 12 volts. Try to set it right on the money, or close enough. 12 volts set, and I'm going to set the current limit. Right now it's set to 80 milliamps. I'm going to bring that up. Probably going to go about 3 amps, and you'll see why momentarily. So these modules are fantastic, but they are a little slow to adjust. And 3, close enough. Set that. Okay, so let me set one aside. We'll start with this guy here. And generally what happens is red is positive, black is negative, and white we'll talk about in a minute here. So I'm going to plug the negative in here. These are DuPont headers, so they do not carry current very well. So that might actually cause resistance, but we'll see. Okay, so I've got black on the outside, red on the middle. So black on the outside, red in the middle. And go. It's running. It's running pretty slow though. What was the RPM on this thing? Doesn't seem to say. Interesting. Alright, let's check the current. It does blow quite a bit of air, but not that much. So we can check the current by hitting OK here. 137 milliamps. Interesting. It should be going faster than that. Should be drawing more current than that. And even these DuPont connectors should be able to transmit more than that. So what happens if I slow it down? The current should go up when you add resistance. Oh, barely. Interesting. This thing doesn't spin all that fast. Maybe that's why it was in the scrap heap. This is the power, voltage, current. Interesting. Oh, 12 volts. Yeah, it's going fairly slow. Let me just ramp up the voltage here. That's a bit better. You know, maybe we're seeing a voltage drop in the supercap video. This was reading a bit low, so let me just check it. Put my meter here to DC volts. I may have to recalibrate this thing. So there and there. No. 14.44, and my screen is showing 14.47. So that's interesting. Not sure why this thing isn't pulling that much current. Let's try the other one. I'm going to lower this down to 12 volts. Simply because I don't know if the other one will actually go faster. Okay, set. Alright, so we'll remove this guy. We put in this guy. So again, red to the middle. And black to the outside here. There we go. And we're going to power this on. This guy's also running very slowly. It's barely using any current at all. That's interesting. Alright, well, let's take a look sort of inside, will you? I'm going to try to take this cover off here. I don't really know if that's really inside, but there's a few clips holding that in. One there, one over here. Come on. I don't want to break this though. I'm not done with it yet. Barely did anything. Okay. Now do you see this device over here? There? I believe, I could be mistaken, but I believe that is a temperature sensor. And I think if this thing gets going, if this thing gets hotter, I think the fan will turn quicker. I'm not sure, but let's see if we can make it happen. So how are we going to warm this up now? Can't exactly get my finger in there. Can get my soldering iron. I'm going to set it down low and see if this thing accelerates when I touch the tip onto that thing. So I set it down 200 degrees Celsius. I'm going to hit OK here. Alright, and how will you know if it accelerated? Well, I'm going to put it on, oh there we go, it's already on current. So you should be able to see an increase when that thing gets hot. So, going left-handed here. It does not seem to be accelerating. Some of you are going to think it's a tachometer. I don't think it's a tachometer. Nope, that's not increasing in speed. Okay, let's check something else out. So I'm going to disconnect these. I'm going to connect my multimeter here in DC volts. So I'm going to connect the black to the black. Actually, why am I in volts? I should go in ohms. So black to black. And I'm going to take this red here and put in the white. I'm hoping that I'll be able to read the resistance of the sensor. Nope. Cannot read the resistance of the sensor. Okay, so then I'm going to put this in frequency and see if the white wire is for a tachometer. Can't tell. This testing is very inconclusive. Alright, let's see if I can go into ohms mode and connect directly onto that sensor. 1 and 2. Aha! I am getting a resistance reading now. It's very high. See if I can touch this now and see if the resistance will change. Yep. There we go. So that is a NTC, negative temperature coefficient. As the temperature goes down, the resistance goes up. Okay. Or sorry, as the temperature goes up, the resistance goes down. Okay. So I guess I don't really know what to do with this thing aside from let's put more voltage to it and see if we can run it super fast, and then maybe we'll open it up after and check out the carnage. I'm going to turn off my soldering iron. Okay, so turn this on. This is at 12 volts, so ramp it up. $20. Still only taking 200 milliamps. It is handling it quite easily too. It's 5 watts right now. Don't know how high it'll go. 25 volts now. Running at 8.5 watts. Peaking almost 10 watts. Something woke it up. That scared the crap out of me. It just started going ballistic all of a sudden. That's interesting. Smells a little bit like hot. It just went full power and just enough thrust to make it move all the way around. Let's move this back to 12 and maybe somehow... Oh yeah, it's going full pop now. I wonder what happened. I wonder what we fried. So it's only pulling 0.7 amps still. Oh yeah, have you ever jammed something in your vacuum cleaner and the motor started going really loud and you thought you'd destroy it? Well, that's actually not you increasing the load on the motor. What you're doing is you're stopping the air from flowing in, and so the resistance will actually drop. The resistance to flow will lower, and actually the amperage should go down, and I can prove that to you. There we go. The RPMs are up higher, and so it draws less current, so you're not actually damaging your vacuum by doing that, unless of course you're over revving it. So yeah, I'm not sure what we did there by overvolting it, but it sure runs like a hot damn now. Let's see if we can get the same result out of the other fan by making it run that long, and if not, then we'll have to overvolt this guy too to break whatever it is that we broke in the other one. Definitely startled me. That was awesome. Alright, and go. Yeah, still very slow. We're going to give this a little bit and see if it wakes up like the other one did. This is probably running very low RPM. I wonder if it's a enable signal from this one to this one, but I don't think so because it says S like censored, not PWM controlled. I can try sending 12 volts down that line and see what happens. These contacts are exposed here. Oh, I guess I could just plug this one in. So plug that in there. Nope. Giving it power or ground doesn't do anything. That's interesting. I wonder if we burnt something by going up higher. It's going pretty quick now. .26 volts, 1.4 amps. This one's much more resilient than the other one. Interesting. I want to see if this thing is removable. If not, well, that's kind of the end of the video. Or if it looks like a lot of trouble, I'll say it's the end of the video. And then this will have to go for another day. Let's see here. Ooh, there's a little kind of a snap ring dilly. Well, you know what? I'll leave it up to you guys. Do you guys want to see the inside of this? If so, leave it in the comments below. And if not, well, I hope you found this informative. And once again, thanks for watching.